The core to stable dominant designs are regulations and standards. What do I mean by that? Well, here's a small fluorescent light bulb. These things, fluorescents have been used for years in businesses, in buildings, industrial, commercial kind of stuff, but they weren't ubiquitous in the home, even though they're incredibly energy saving compared to the traditional incandescent light bulb. Why? It wasn't until they figured out how to make the ballast smaller and then put it together with the standard socket so you could put it into any light fixture that the fluorescent light bulb became ubiquitous. In other words, there's a standard out there for plugging things in. We see plug-in standards all kinds of places. Here's another plug. Let me zoom in one more time. This is the plug for a microphone. If I don't have this, it doesn't work anymore. That's why I need the adapters to plug it into my iPod or my MP3 player. Here's another kind of plug. We have different plugs in different countries, but this is a power plug. This is an old pencil sharpener, electric pencil sharpener. Here's the plug that goes into the wall. There's a standard for that. There's the RS-232 port. Standards solidify, ossify dominant designs so that you can design and know what's going on. Notice that when you try to break away from a dominant design, there's a penalty. A number of years ago, we did a project for a small firm out in Arizona. They had designed and invented a new type of plug. In the plug, there was a little bar and there was a piece of metal, almost like a solder, that held the two prongs together. If the plug overheated, the solder melted, the prongs split apart. It was a safety device, so a socket, or rather a plug doesn't overheat, burn down the house. Very attractive from that standpoint. Cost almost nothing to make. So you would think that it would come in no-brainer. The problem was when they designed it, they forgot they needed UL certification. And they didn't design the plug to be easily certified by UL. Because they were a small money, they couldn't afford the fee that UL charges if you want to develop a new testing protocol. Thus, they had to bear the full cost. That was the showstopper for them. They were not able to get to market. So, dominant designs are more stable where standards or regulations enforce them. That happens over time because there are certainly utilities for everybody to have the same way to plug things together or to understand what's going, train for the dominant design, develop certification programs for people so they can work with technology based on the dominant design, like people get a radiography certification to work with X-ray machines and so on. There is an incentive to keep the dominant design as long as it's generating utility. It's only much later in its life cycle when new technology comes in that is so far superior that it will typically bust the dominant design. That new technology tends not to come in as a direct competitor to the dominant design. It comes in some kind of little niche field, like our zipper came in as a competitor to the buttons, but it came in saddlebags for the military and galoshes, not as a ubiquitous thing for clothing. Okay. Now that we've introduced dominant designs and we've talked about how they get solidified and stabilized, let's move on to our next